Okay, so to find the mean, what do we have to do? We add them up. So 6 plus 10 is 16, plus 11 is 27, plus 13 is 40, plus 20 is 60, divided by how many are there? And there's 5 of them. Gives us a mean of 12. For a median, what do we do? Median is the middle number. So to find the position of the middle number, it's 0.5 times n. N is the number that are in the list. This 0.5 times 5 is 2.5. Since that's a decimal, we will round up. So that's the third number in the list. Third number in the list is 11. So 11 is the median. How do we find the range? The range is the max minus the min. What's the largest number in this list? 20. Minus, what's the smallest number? 6. Get a range of 14. Finally, standard deviation. What's the first step in the standard deviation? Find the mean. We got the mean is 12 already, so we got the mean. What's your second step? What do we have to do to each number? Subtract the mean, right? So 6 minus 12 is negative 6. 10 minus 12 is negative 2. 11 minus 12 is negative 1. 13 minus 12 is 1. 20 minus 12 is 8. If I add them up here, what should I get at this point? If I add up that column, it should come out to 0. If I don't get 0, it means either I calculated my mean incorrectly or I subtracted wrong somewhere. What's step 3? Square them. So negative 6 squared is 36. On your calculators, make sure you put parentheses around them, or it'll try to tell you that's negative 36, but any number squared should be positive. Negative 2 squared is 4. Negative 1 squared is 1. 1 squared, 1. 8 squared, 64. What is step 4? Find the sum or total. Add them up. So that gives us what? 106? So step 4. Step 5 is to divide by n minus 1. What's n here? How many numbers in the list? 5. So n minus 1 is 4. So we're going to divide by 4. It's 26.5. Now that number there is actually has a name of its own. That would be called the variance. We're not looking for the variance, though. We are looking for the standard deviation, which requires one more step. Step 6 is to do what? Square root. So 26 square root of 26.5 is 5.15. That's the standard deviation. That's telling us on average how far each number is away from the mean, pretty much. Any questions? Okay, we've only got a couple of new topics left for tonight. Then we'll take some time to review for that last test coming up on Tuesday. I want to talk about percentiles. So to talk about percentiles, I need a list of numbers again. And I'm going to put these numbers in order from smallest to largest as I make them. If they're not in order from smallest to largest, that would be the first step in doing anything with percentiles. So there's my set of numbers from smallest to largest. First thing I'm going to do is I'm going to figure out what n equals. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n equals 12. There's 12 numbers in my list. To find a certain percentile, or what number is in a certain percentile, if I'm asked to find the 30th percentile, just like we did with the median, we have to find the position. To do that, we take our percentile, 30th percentile. 30% is 0.3 as a decimal. And we're going to multiply n, which is 12. 0.3 times 12 is 3.6. Also, just like with our median, since that is a decimal, we round up. So 3.6 becomes the fourth number in the list. So that means the fourth number in the list, or 16, is the 30th percentile. Let's say I ask you to find the 75th percentile. So what I'm going to multiply 12 by now? What's 75% as a decimal? 0.75. We get 9. Well, when we're doing our median, if we got a whole number, no fraction or decimal, what'd that tell us about our position? It's between. So it'll be between the 9th and the next one, the 10th. So we get a 9, it's going to be between the 9th and the 10th. So there's the 9th number and the 10th number. It's going to be between 25 and 29. So we'll add them together and divide by 2. If you do this on the calculator, you do 25 plus 29. Make sure you hit equals before you divide by 2. 27 is the 75th percentile. In your notes, I want you to find the 60th percentile for me quick. I'll pause for you guys. So to find the 60th percentile, it's 0.6 times n. So 0.6 times 12 is 7.2. What's that tell us about the position of our 60th percentile? We round up. It's a decimal, we round up to the 8th position. So it is the 22. How many of you had 22 for the 60th percentile? Good deal. Any questions on that? So the other side of it would be, I'm going to actually bring my list down here. I might ask, what percentile is the 25? To find the percentile a number is in, it's equal to the number that are smaller than that number plus the number that are equal to it divided by 2. And that's all divided by n, the total number in the list. So here we have the 25 we're looking for. How many numbers in that list are smaller than 25? 8 of them. So we're going to add to that. How many are equal to 25? Only 1. So 1 over 2 divided by 2 over n is 12. So this is 8.5 divided by 12. We get 0.7083. Now that's not a percent, it's a decimal. To make it a percent, we move it over 2 spots and we'll round it to the nearest percent. That is the 71st percentile. So 25 is the 71st percentile. How about the 18? Find its percentile. How many are smaller than the 18s? 4 plus, how many are equal to 18? 2, so it's 2 over 2 divided by 12. So there's 12 in the whole list. Yeah. Oh, gotcha, yeah. 4 plus 2 over 2 is 1, so that's 5 divided by 12, which is 41.66, so 0.4167 we'll round it to. And to make that a percent, we're going to move it over 2 spots. 41.6 or 42, so it's the 42nd percentile. What do you think? Not bad? Okay, so the next concept we're going to talk about is quartiles. You're just saying you're going to pull out a test for somebody. There you go. Are actually pretty simple. It is the numbers that divide the data into 4 equal sections. Now, if you think about it, let's say I have a piece of string. I know it's a really fat piece of string, but I want to cut it into 4 equal pieces. How many times do I have to cut it? 3 times. 1, 2, 3. So there are only 3 quartiles. 3 cuts divide the data into 4 equal pieces. So I'm going to start out with a list of numbers again. And I am going to put them in order from smallest to largest again because we would need to do that. So here I have 10 numbers, n equals 10. So this here, this cut would be called the first quartile, or Q1 I'm going to call it. The first quartile is found similar to doing the, well, it's not similar, exactly like doing our percentiles. We find the position, 0.25 times n. Now, if you look at that, 0.25 is just 25%. This is the exact same as trying to find the 25th percentile. In fact, the first quartile is the 25th percentile. So this is going to be 0.25 times 10, or 2.5. What does that tell us about the position of our quartile? It's a decimal, so we round up. It's the third number. It's 21. So the first quartile for this data set would be 21. Second quartile. Well, what are we going to multiply n by for this one? Second quartile would be what percentile? 50. Would be 0.5. Gives us 5. That means it's between the 5th and 6th number. So between 25 and 26. Add them together and divide by 2, you get 25.5. Now you'll notice that's the 50th percentile, 0.5. Also, what else did we multiply n by 0.5 to find? It was the median. So the second quartile is the 50th percentile. It's also the median. So that was Q2, or the median right here. So now we're going to find the third quartile, Q3. Now we're going to do the same thing, only 0.75 times 10. Gives us 7.5 as its position. Again, the same as the 75th percentile. So 7.5 is going to round up to the 8th number in the list. That would be 34. Is the third percentile. And you can see this does divide the data up. Because we have, here's our first quartile, second quartile, and third quartile. It does divide the data into 4 equal pieces. There's 2 numbers in each quartile. Quartiles are actually very handy for plotting data and looking at distributions. And we make something called a box plot. And a box plot includes 4 things. It's actually called a 5 things. It's actually called a 5-number summary. So for the data set we had up here, we'll bring it down with me. We have the minimum, the smallest number, is 11. The first quartile, 21. The median, or the second quartile, is 25.5. Third quartile is 34. And the maximum, or the largest number, is the 45. And what that 5-number summary can be used for is making, like I said, that box plot. To make the box plot, we make a number line. So we have to go from the minimum up to the max. So we got to start at 10. 11 at least, 15, 20, 25, 30, 35, 40, 45. So we got the full range of the data. The minimum's at 11, so I'm going to put a dot for the minimum. Maximum is 45, I'm going to put a dot for the maximum. All the other ones, I'm actually going to put a small vertical line. So the first quartile is 21. Put a small line like that. Median's at 25.5. I'm going to put a small line there. Third quartile's at 34. Put a small line there. I can connect these to make a box. So it's called a box plot. And it's sometimes called a box and whisker plot because now from the ends of the box, from the first quartile, the center of that line, I'm going to draw a whisker out to the minimum. From the third quartile, the center of that line, I'm going to draw a whisker out to the maximum. These box plots, or sometimes, like I said, sometimes called box and whisker plots, can tell us a lot about the distribution of our data. The smaller a section of the plot is, notice there are 4 sections, 1, 2, 3, and 4. There's 4 sections. The smaller that a section of that box plot is, the more compact, the closer together the numbers are in that portion. The bigger it is, like here, the more spread out those numbers are. So if I give you like this, which box plot would you expect that to be? Expect it to be this one or this one, first or second? The first one, because here each section is the same size. The numbers are equally spread out. Here, this is saying the numbers are a lot closer together in the middle. That one might represent a set of numbers that look more like this. Like that. That would be more representative of what we have going on there. Okay, enough about that. That is the end of our new material on statistics. So, I'm going to